Welcome back, everybody. This is going to be part 1 of 2 in my lecture series on dividing polynomials. In this video, we're going to learn how to use long division. Let's get started. I think there's no better way to learn this process than by just jumping into some examples. But really quickly before we do, I would like us to recall just how the regular long division algorithm works. And let's say I'm trying to compute 972 divided by 3. Well, what I would do here is my divisor 3 goes on the outside. My dividend 972 goes on the inside. And now I'm going to look at my divisor and see how many factors of this, or how many copies of this, fit into the leading term, 900. Right? Or 9. And I would say, well, 3 copies fit into that because 3 times 3 is 9, and that's as close as I can get without going over. Right? So I would subtract 9, I get 0, I'm going to bring down the 7, and now I look at what I have left, right? The 7, and 3 goes in there 2 times without going over. That gives me 6. It's going to leave me over with 1. I bring the 2 down. And now I know 4, it goes in 4 times, and that will give me a remainder of 0. Now, let's see how this changes when we have polynomials. The good news is, it doesn't change much. Still, x plus 3 is my divisor, it goes on the outside, and x squared plus 10x plus 21 is my dividend. So it goes on the inside. And I ask myself, and sometimes it's helpful just to look at the leading term here, this times what fits into x squared without going over? The answer is x. Notice when I multiply through by x, I get x squared plus 3x. Right? And so x squared is as close as I can get to x squared without going over. So now I come through and subtract it all. Notice these guys cancel out. I'm left over with 7x. And now I do the same process again. So how many copies of x plus 3 fit into 7x without going over? The answer is 7 of them. 7 of them. So I multiply through by 7, I'm going to get 7x. Oh, and I forgot to bring down my 21 plus 21. And of course now I go through and, subtract everything off. And I am left with a remainder of 0. So what do I get? I get that x squared plus 10x plus 21 divided by x plus 3 is x plus 7. And for this problem, of course, we can verify that because this fraction can be simplified further. And I'm going to erase some of my division problem here. This guy can be simplified into x plus 3 and x plus 7. And then my x plus 3's cancel top and bottom. So you may be thinking, well, why go through the trouble of learning this new method then? And the answer is, for problems like this next one, let's try this one. 3x minus 1 is going to be my divisor, and 6x cubed plus 16x squared plus 12x minus 5 is going to be my dividend. So I need to ask myself, how many copies of 3x fit into 6x cubed? The answer is 2x squared of them. Because when I multiply 3x by 2x squared, I get 6x cubed. And then, of course, I'll have a minus 2x squared. And then I need to come through and subtract them here. My 6x cubes will cancel. I'll be left over with 18x squared, and then I want to bring that plus 12x down. From here, I see that 6x copies fit into 18x squared, because 6x times 3x is exactly 18x squared. And then, of course, I'll have an extra minus 6x, and I'm going to come through and subtract everything off. My 18x squareds will cancel, and I'll be left with 18x, and I'm going to bring down that minus 5. So, of course, my final factor here is going to be a 6. That gives me the 18x I need. But now I've got this minus 6. And I'm going to come through and subtract everything. My 18x is canceled, and I'm left over with 1 still. But notice 3x minus 1 doesn't divide 1, right? There's nothing without getting into some rational functions, which we're not going to do here. We're going to stick with polynomials. I end up with a remainder, right? I have a remainder of 1. So let's see what that looks like. This tells me that I can factor out a copy of 3x minus 1 from this big cubic polynomial. When I divide it by 3x minus 1, I get 2x squared plus 6x plus 6, but then I have a remainder of 1 that I still need to divide my 3x minus 1 by, right? So I still have this remainder. All in all, this is our answer. In this video, we saw how to use long division to divide polynomials. In the next video, we're going to learn a new division algorithm called synthetic division. Catch y'all in the next one.